So there is one more type of limits involving infinity, and this is limit as x approaches infinity or x approaches negative infinity. So, for example, consider the following example. Limit as x approaches infinity of the following fraction: 2x squared plus 3x minus 1 over x squared minus 5x plus 3. How can we calculate this limit? Again, same like for the previous limits, there are three ways to calculate this limit. We can calculate it numerically, we can calculate it algebraically, and we can calculate it from graphically, when the graph of the function is given. So first I want to explain numerically. Numerically means that we are going to plug in a bunch of x values into this function and see what those what are the corresponding function values. Now, what should be the x values that we plug in? Well, since x approaches infinity, we already know what this means. It means that x values grow without bounds. So x values, well, they are large, and that means that they grow. They grow without bounds. So what numbers can we take? We can take some big numbers, for example 50, and the next number should be even larger, such as 100, and the next one should be even larger, like 1000. So the simplest numbers to take are 1000, 10,000, maybe 100,000, etc. In fact, we don't have to take specifically these numbers. We could take any numbers as long as every next number is larger. And now we will plug them into the function, again using calculator feature table. So we need to enter this function into the calculator, which is again using all the proper syntax: 2x squared plus 3x minus 1, close parenthesis, divide, open parenthesis, denominator x squared minus 5x plus 3, close parenthesis. And now I go second table for the table feature. I will press delete to remove all the x values that I previously used. And now I will enter these x values. 50. When I enter 50, the answer is 2.2854. Now, from one only x value, it's difficult to guess what the function values approach, so I will try some more. 100 is 2.1361. 1000 is 2.0131. Now it's quite clear already that it probably approaches 2. But let's try just one more. 10,000. So the answer is 2.2013. And from here it's quite clear. This number is very close to 2. So we can tell by watching these function values, we can tell that they approach 2. And that's why the value of this limit is 2. So this is how to calculate this limit numerically. And again, I want to do one more example similar to this example, but now x approaches negative infinity, because x could approach infinity or negative infinity. By the way, when x approaches infinity or negative infinity, we cannot talk about one-sided or two-sided limits. These types of limits, they are always one-sided, because you can only approach infinity from one side. Like you can only grow positive, and that x values could grow positive, and then we will say that x approaches infinity. Or x values could grow while being negative, and then we say x approaches negative infinity. Either way, it's only one side, or a one-sided limit. So here is one more example. Let's do the same example, only let's say that x approaches negative infinity. Again, it will be a fraction 2x squared plus 3x minus 1 over x squared minus 5x plus 3. Same thing like here. Since x approaches infinity, this means that x values grow negative. X values grow can try x and y1. So we can try negative 50, for example, and the answer is 1.76. We can try negative 500, no, negative 100 first, negative 100, and the answer is, the function value is 1.8756. Once again, just from a couple of x values is not clear. It seems like they do approach 2 as well, but maybe they approach 1.9. It's not clear yet, so let's try some more. So negative 1000, that was negative 100. Now negative 1000, it's a 1.9871. Now we can see it's pretty close to 2. Just to double check, let's try negative 10,000. So negative 10,000, here we have 1.9987. This number is very close to 2, so that's how we know that definitely y values approach 2. So approach 2, and therefore the answer to this limit is 2. So this is how to calculate limits when x approaches infinity. They are called limits at infinity. Limits at infinity. So there are two types of limits. Limits when x approaches a number and function values approach infinity. Those limits involve infinity. And there are limits where x values approach infinity and function values approach a certain number. So this is how to calculate limits as x approaches infinity numerically. And same like with all the other limits, there are three ways to calculate limits: numerically, graphically from graph, and algebraically. So next I want to show you how to do a limit algebraically. Next I want to show you how to calculate a limit from graph.
Okay. Next.
Next, I will show you how to calculate limit as x approaches infinity or negative infinity from graphically. So I will assume that graph of a function is given. Assume that a graph is given, and in certain situations we can tell from the graph that the function has a limit as x approaches infinity or negative infinity. For example, let's say that the graph is given like this. So the function may have behavior like this. So again, function values, this is the x coordinate, this is x-axis and y-axis, and the function approaches a certain horizontal line. This horizontal line also called an asymptote, like we had before, except now it is a horizontal asymptote. Horizontal asymptote. And when there is a horizontal asymptote, it means that if you stretch it further, then the graph will come closer and closer to this asymptote, so it becomes almost horizontal. And this behavior means that the function value will approach the value of this asymptote. For example, this is 1, this is 2. The equation of this asymptote, like equation of any horizontal line, is y equals something. For example, y equals 2 in this case. Therefore, since function values approach 2, we say that the limit as x approaches infinity of this function equals 2, equals the level of this asymptote. Similarly, if the same or similar phenomenon occurs on the left-hand side of the graph, like for example the graph may go like this, and then it approaches asymptote, maybe the same asymptote, maybe different asymptote on the left side, then if this happens, then we say that the limit as x approaches negative infinity of the function equals, again, it may be 2 or it may be different asymptote on the other side, but if it is the same asymptote, then we say that limit as x approaches negative infinity equals the level of this asymptote, which is 2. So once again, here is how to tell limit at infinity from graph. It's horizontal asymptote. Right hand side of the graph means limit x approaches infinity. Left hand side of the graph means limit as x approaches negative infinity. So that's how to tell limit, to calculate or to estimate limit of a function as x approaches infinity.